Hi! So the other day I already uploaded a quick overview of how to make an endless runner in the Godot engine. Today I'm making a full tutorial to show you step by step how you can start out. So let's get to it. First of all, I am going to create a 2D scene. Just call it game. And let's see, what is this going to need? We're gonna want a no2D child to be our player, and we're going to want something to put game areas in. So I'm creating another no2D and just call it areas. This one will be empty for now, but eventually it's going to be filled up with various areas via code. So let's build the player. I'm going to move the player down here roundabout. And let's see, it needs a sprite so we can actually see it. Texture. That's a bit small. Let's see about that. How is it here? Scale. How tall? 3? 4? 4 seems fine. For the screen size, you know, gotta fit. Now, let's give the player a camera 2D. This is just so it follows when the player goes up and down. The player isn't gonna go left and right at all. It's only gonna move up and down from jumping and stuff, and moving up slopes. Then we can add another, let's see, we can add a raycast 2D, I guess. Because we want to be able to actually see if we're colliding with the floor. Let's see, make this like 15 long maybe. The exact numbers are a bit of a matter of experimentation, what works for your game. But roughly like that seems fine. Now we need 2 area 2D. 1, 2. One is our hitbox. If this gets touched by anything, we die. The other is our, I don't know, headbox, I guess. Well, then let's be consistent about the B. The headbox is going to prevent us from moving up through ceilings. Now we make a collision shape. Give it a rectangle shape. Now this is the hitbox, so we want it roughly. Let's see. It should of course touch things before the raycast can move us. So roughly like this seems fine for now. Now the headbox needs 1 too. Again, just a rectangle shape will be fine. Make it flat, move it up a bit. Something like that. If we jump up and anything touches this, we don't move up further. Cancels the jump. Yeah, sure, we can save the scene. And I guess we're gonna want some scripts now. First of all, let's add a script to the player, attach script. And let's see, we are gonna want a few things here. onRed_var ray equals with our raycast 2D. And yeah, we're definitely gonna need access to that one. We don't really need a ready function right now, so I will remove that. Let's go function, physics process, that's the important one. Well, first of all, we're gonna want to not fall through objects. So for that we need to check our raycast. So if ray.isColliding, then a few things should happen. First of all, we want to calculate the origin. Let's just shorten that. Not origin. There, that's where our raycast 2D starts. Our collision point is ray.getCollision point. That's a function. Yeah, there we go. And our distance then is just origin.y minus collision.y. I'm taking absolute because that way I don't have to think about which one is bigger. Now var depth, because the distance is how far, if we go on the player, how far away from the player our array is intersecting something. That's the exact opposite of what we want. What we want is how deep are we inside of an object. So that's what the depth is going to be. So we can say array.cast2.y. Since we are going to completely ignore the x-axis, we only care about y, we can just use that. Minus the distance we just calculated. And that tells us exactly how deep we are inside of an object. So now if we do position dot y minus equals depth, then that should work. Let's see, is there anything missing here? Because I think it isn't. Well, let's just try it. I'm just gonna put a static body into the areas. This is temporary, just for testing purposes. Put it down here. Give this a collision shape. Rectangle. Make it longer. Actually, I'm gonna rotate it a bit, just in case. There. Let's see if that works. Obviously it wouldn't right now, I'd need to actually collide with it, so let's see if that works. And it did, it actually pushed us up until we are standing properly on it. Now let's give our player some gravity to make this a bit more interesting. Okay, for that, let's see, let's first define how strong our gravity is. Var gravity is equal to 15, let's say. And we need a y velocity. We don't care about the x-axis, so I'm just gonna do y val. Starts out as 0. And let's define a maximum, because we don't want to start teleporting if anything goes wrong. Like if we fall for a long time, we would start falling through objects. That wouldn't be very fun. Now, do I need anything else here? I guess we only want to apply gravity when we are currently not touching the ground. So var grounded is equal to false. Let's use that. And then we can go in here and say if not grounded, y velocity equals minimum of max y velocity and y velocity plus gravity. How did I type this wrong so often? Right, so in any other case, else y velocity is gonna be 0, because if we are grounded, if we're touching the ground, we don't want any y velocity. And after doing this, grounded is equal to false. Now, in which case is grounded ever true? Grounded is true if this colliding thing here happens. So here at the end, I'll just say grounded is equal to true. And I think that should be it. The position still needs to be adjusted, but I think that seems fine. So let's go in here and say position dot y plus equals y velocity times delta, because all of our movement should account for delta here. And we are falling, but we are stopping here. Nice and simple, all we need. No movement on the x-axis. Now we want to see what happens when this thing actually moves, I guess. So let's see. Actually, before we do that, let's just take a look at jumping quick. So I'm adding another thing here. Var jumping equals false. Because that way we can tell whether we are currently in a jump. And then here I can just add var jump equals input.isAction just pressed jump and not jumping. So the isAction pressed, the jump action, I already defined that before. So if I can just show you here, input map, jump right here. If you don't have that, just add it. I just put the space button, but you can do whatever you want. So if I'm not currently already jumping, and this isn't the case, then jump is set. And then if jumping equals true, and y velocity equals minus 500, let's say. I should probably set that up here. So let's see, var jump speed equals minus 500. Jump speed. Yeah, that's a bit cleaner. Now that part is done. We still need to go in here and say jumping equals false. And we need to make sure that our colliders here don't actually cancel our jump. To do that, we can just say if not jump, do that stuff. Because if we don't have this, then even though this stuff moves us up, it is actually going to cancel our jump here unnecessarily. It should only cancel our jump after we reach the ground again. It doesn't matter for this, by the way, whether you are... And we're jumping fine. That's actually, I think, the player pretty much done. We can take a look after the area movement is a thing. So let's add a script to the game scene. Now, what are we gonna do here? Do we need a ready function? I guess we want at the very least to randomize in here. And probably spawn in some stuff later. Right now we don't care about that yet though, but we do want a speed for the map to move at. Let's set it to 200 and say func physics process for area in areas. So anything that's a child of this thing here is automatically going to be affected, no matter what's in there. We can't say dot areas, we need areas dot get children. I'm not saving this up here because this is going to change occasionally. So for each area we can say area dot position dot, why is this not updating? X. There we go. Minus equals speed times delta. Okay, that's pretty much all for the movement. So whatever is in there, it's just gonna be moving to the left at all times at this speed up here. So technically, if you want the speed to increase over time, just change this variable and this is gonna change. Let's play it, and it moves, and we get pushed up by our raycast. Simple. Now, that is actually a big chunk of stuff out of the way. The last thing we need at this point is to actually make some areas we can work with. So I'm actually going to keep the static body 2D here, but I'm going to change the collider to a collision polygon, simply because that gives me a bit more options of what it can look like. So if I'm just gonna, let's see, start at roughly the player height, and I can just define a few things. Make this slide up here, and let's slide it up quite a bit. Go like that, go down here, and finish it. So that's our first one. Now, let's duplicate it. Actually, can I just change this? Ah, no, I don't have to make it unique here. I only have to do that for collision shapes. So it's gonna start in the same point because that's where the player is at the start, so that's a good place to start it. Then I can just do a few points. You know, I just want them to be visually distinct for now. I'm not trying to actually go into level design. You can figure out what you want your levels to look like yourself. I'm just showing an easy way to get this set up for starters. Now, right now, I am making every one of these chunks the same size, which is the size of the window. So I'm going to spawn one here, then one there, and then they're gonna move to the left until the one that spawned off to the side is here in the center, and then the one here is gonna be deleted and a new one spawns here. That's how I can assure the endless runner does indeed run forever. Which does mean I don't have to account for sizes or them going at different heights or something like that here right now. You can totally do that, there are plenty of options. But I just want to show the simplest and quickest version to set this stuff up, and the details can be adjusted later. Now, let me make one more, just so I have 3 examples to work with. And for this one, let's see, I'm actually going to be... Yeah, let's make this one pretty straight. And add a second collision body, which I can move up here. And then move some points on it. No, I didn't mean to make new points. I meant to move the existing ones. So I can do this. And I can put this up here. And I can put this up here. And that should be fine. Just to have some examples. Now I'm going to save each one of these as a separate scene. Alright, I already had a segments folder. Well, it's fine, I'll just make a new one, because that already had some stuff in there. And now we can use it freely. So this one here, save branch as scene. In segments, and I just call this A. Now this one, save branch as scene, B. Now this one, save branch as scene, C, save. Delete them all, we don't need them here. And the player is floating in emptiness once more. Now, we're gonna want the scenes to actually be known over here. So what we can do is var scenes equals, or I guess segments is more accurate. Segments, preload, res : / segments / a.tscn. Easy names to remember, that's why I use them. Segments / b.tscn. Preload res : / segments / c.tscn. There, now our game actually knows what all of the possible segments are. If we have more in that folder, we can just go there. And that should be fine. Now, let's define a spawn instance function and set some default parameters. X equals 1024, y equals 0. By default, that way I don't have to think about it much later. So actually it doesn't matter, because there's only like one case where this matters much. Let's just say x and y var inst equals scenes at position. Now we want a random instance from up here, so we can just say random integer mod length of scenes list. Then we take the instance from that, And if I don't have anything... Alright, because I renamed it earlier. Consistency. Segments. Then this instance, position needs to be set to vector 2 x, y, and areas gains this as a new child. And that's really all we need to spawn in a new instance. Now at the very beginning we want to spawn in 2 instances right away. So let's just say spawn inst 0, 0 and spawn inst 1024, 0. Let's take a look. Okay, I have the height wrong. Why do I have the height wrong actually? This is where it should be for 0, 0, no? Position is not 0, 0 like this. Ooh, okay. In that case, let's make this 0, 0. So I wasn't paying attention there. And just bring down the entire area. And that should be fine. Like, optimally, I guess it would be great if we had the areas roughly around the player's feet, because that way it's easy to say that anything at 0, 0 is exactly where the player is gonna spawn at, potentially, and everything after that we can go ham. So, let's see. Is that fine? It is fine. So we can move up here, we can fall down here, everything working good, and the map ends because nothing more is spawning. Nice. Now, game script. Let us spawn something new and get rid of the old stuff. So, after we move here, if area.position.x is less than minus 1024. So, if our thing is more than 1 screen width off to the side on the left, we can delete it. Q3, so it's safe to delete. And spawn a new instance while we're at it. So spawn inst at area.position.x plus 2048, 1024 times 2, 0. And where it's going to be spawned off to the side, basically 2 screens over. Now optimally we should never notice any of these disappearing or appearing. Whoop. Oh, that's not quite working, is it? Alright, I don't think I actually programmed in the ceiling check yet. That's fine, we can do that in a moment. I also haven't programmed in depth, though. That's fine. But everything else seems to be working as intended, which is nice. So let's do these last 2 things. We already have the hitbox. So let's just say if a body enters, we trigger this. Do the same thing here. If a body enters, trigger this. On the player, please. Now, if the hitbox is entered, for now I'm just going to delete the player. It's not going to stop the background from scrolling, but you know, you can put some more work into that. I just want to make sure it's visible what is going to happen. And here, in the case that our head entered a ceiling, we just say we don't go up anymore. So our y velocity is the maximum of our y velocity and 0. So if we're falling down, we just keep our velocity. If we're moving upwards, we set our velocity to 0. Let's give that a shot. Okay, we now don't get stuck when hitting a head. Now let's try to die. I haven't actually built in a whole lot of ways to die, but if I just don't move here, I'm gonna crash in here and die. And that works nicely. Yeah. that is pretty much the very basics of how you can start out with making an endless runner. If you want to expand this, you can adjust the system a little to account for different sizes of segments. That way you can have larger segments, smaller ones, however you like, and spawn them in. And you can account for having them at slightly different heights, so if you want to go up over a few segments or down occasionally, that's fine as well. Lastly, of course, this jump mechanic here, which always jumps the exact same height and doesn't have a lot of very smooth movement. That bounces a bit when going downhill on slopes and stuff like that. There's a lot more you can do to make this player controller feel better during gameplay. This is really just the very beginnings of a endless runner. Don't use this as is. Use this as a basis and see how you can make it better. A proper jump, and with all of the things you can do to make it feel good, would need an entire tutorial all on its own. And well, I suppose for more complex map spawning, it would be possible to have a separate or an additional tutorial later, showing how you can make these maps more interesting. But for now, this will be all for today. Bye.